In this video, we're going to talk about reference numbers or reference angles. They mean the same thing. Importance of a reference angle is because it forces you to understand the first quadrant. And once you understand the first quadrant of the unit circle, the rest of the circle you've got memorized. You just switch the signs based on what quadrant you're in. So then I can use the first quadrant to find any value on the unit circle. If I were to look at the unit circle and I sweep out an angle, and here's my terminal side of that angle is obviously bigger than 180 degrees, but the reference angle, we can use that to find the point on the unit circle that intersects with that terminal side very easily by finding the angle that the terminal side makes with the x-axis. So if I figure out what this angle is, that's going to give me the corresponding ordered pair in the first quadrant. So all I need to know is that first quadrant ordered pair, and then I switch the signs depending on what quadrant I'm in. So by understanding reference angles, I can use the first quadrant to find any point on the unit circle. So in the next few examples, what I want to do with you is practice finding the reference angle. In the examples after that, I'm going to show you how you can apply it to finding angles on the unit circle that are not in the first quadrant. Okay, so in the first example, let me draw the unit circle. For the angle 5 pi over 6, 6 pi over 6 would be pi, which would be here, or I can write it as 6 pi over 6. That would be if I sweep open to the negative x-axis. But 5 pi over 6 is pi over 6 radians short of hitting that negative x-axis. So my reference angle is going to be the angle that that terminal side makes with the x-axis. So my reference angle here is pi over 6, which means if I want to find the ordered pair for the angle when I sweep open 5 pi over 6, it's going to be the same as this point over here for pi over 6 when I sweep out. It's just that the signs will be different for the ordered pair. Okay, for part B, seven pi over 4, it's 1/4 pi, or pi over 4, short of 2 pi. Here's 2 pi. 2 pi would be 8 pi over 4. So 7 pi over 4 would be if I sweep open, here's my initial side, if I sweep open, and this angle here, I would be pi over 4 short of 2 pi. So the angle that the terminal side makes with the x-axis is pi over 4. That would be my reference angle, which is telling me if I open pi over 4 this way, this point and this point will be exactly the same other than sign changes. For example C, here's my unit circle. 3 pi over 3 is the same as pi. And because this is negative, I'm going to be opening in the clockwise direction. So here's my initial side, and I'm going to open up, but I'm not going to hit 3 pi over 3. It's before 3 pi over 3. It's negative 2 pi over 3. So this angle that it makes with the x-axis would be pi over 3, because if I add pi over 3 to 2 pi over 3, that's going to give me a full pi. So my reference angle is going to be pi over 3, which means if I open pi over 3 in the first quadrant, this point here and this point here are going to have the same ordered pair other than sign changes because of what quadrant it's in. Now this one's a little bit out of our comfort zone, but if I think about it, I know that a full circle is 2 pi radians. I know that this is radians because it doesn't have the little degree symbol up there. So if I put in my calculator 2 pi, 2 times pi, and I put it in decimal form, 2 pi in decimal form as an approximation is 6.28, rounded to 2 places. This here is 1.5 pi. So if I take 1.5 pi and put it in decimal form as an approximation, that's 4.71 radians. So 5.8 radians is going to start here. There's my initial side, and it's going to swing open somewhere in the 4th quadrant because 5.8 lies between 4.71 and 6.28. So I just use my knowledge of the major angles and radians, put it in decimal form, and I can check to see where it falls. So I know 5.8 radians falls in the 4th quadrant, which means in order for me to find my reference angle, that would be whatever 2 pi is, and I would have to subtract 5.8 to see what that difference is for the angle. So I would take 2 pi minus 5.8. That would give me my exact answer. If I want an approximate answer, I know 2 pi approximately is 6.28, and if I subtract 5.8, that's going to give me approximately 0.48 radians would be my reference angle. If you want it as exact, just leave it as 2 pi minus 5.8. Okay, now this is where we're going to apply our understanding of reference angles. This is asking us to find the terminal point, which is the point on the unit circle where the angle sweeps out. 11 pi over 6, here's my unit circle. 11 pi over 6 would open like this. Here is my initial side. I would open it like this because this is 2 pi, which is 12 pi over 6. That's the same as 2 pi. So I know it's going to be a little bit before 2 pi. So exactly it's going to be, if I take this difference, it's going to be pi over 6, right? It's 11 pi over 6 subtracted from 12 pi over 6. So my reference angle is pi over 6, which tells me that if I look at my unit circle at pi over 6, my terminal point is the square root of 3 over 2 and 1/2. So that means this point here for the terminal point for 11 pi over 6 is going to be the same as the terminal point for pi over 6. The only difference is a sign change. So because this is in the 4th quadrant for 11 pi over 6, that means my x is positive and my y is negative. So my final answer is going to be the square root of 3 over 2, negative 1/2. This is my ordered pair, or my terminal point, for the angle 11 pi over 6. And I used my reference angle to figure it out. I just switched the sign depending on what quadrant I'm in. For the next example, it's negative 4 pi over 3. Negative means I'm going to open in the clockwise direction. So this is my initial side. I'm going to open to 3 pi over 3, which is pi, and then another pi over 3 to get my negative 4 pi over 3. Right? That's 3 pi over 3 plus another pi over 3 to get 4 pi over 3. So my reference angle that it makes, the terminal side with my x-axis, is pi over 3. So I know this point and the point for pi over 3 here in the 1st quadrant are going to be exactly the same other than sign changes. So if you look at the unit circle for pi over 3, the ordered pair for pi over 3 is positive 1/2 square root of 3 over 2. in the second quadrant, my x is going to be negative and my y is going to be positive. So for negative 4 pi over 3, my terminal point is going to be negative 1/2 square root of 3 over 2 because we're looking at the second quadrant. The last example, part C, says 13 pi over 4. 13 pi over 4 is 12 pi over 4 plus 1 more pi over 4. 12 pi over 4, this is 12 pi over 4 plus another pi over 4 to get 13 pi over 4. So I need to go 12 pi over 4, which is 3 pi. Here's my initial side. I open 1 pi, 2 pi, 3 pi, and then another 1/4 pi. So my reference angle is going to be pi over 4 because that is the angle that my terminal side makes with my x-axis. So I know that this point here is going to be the same as the point over here when the angle sweeps open pi over 4. The only difference is, since this is in the third quadrant, both my x and my y are going to be negative. Since I know at pi over 4, it's the square root of 2 over 2, and the square root of 2 over 2, the terminal point for 13 pi over 4 is going to be negative square root of 2 over 2 and negative square root of 2 over 2. That would be my terminal point for 13 pi over 4. So you use your reference angles that are always going to be angles in the first quadrant to find the points on the circle of the angle that is being asked of you, and you just switch the signs depending on what quadrant you're in.